Good afternoon, class. We are looking at exam 4 review, covering sections 4.4, 4.6, 5.2, 5.3, and 5.4. So basic integration formulas, when you have a constant n number is kx plus c, the power rule is extremely important. X to the power of n results in 1 over n plus 1, x to the power of n plus 1 and a constant. Constant multiple says if you multiply a function by k, you can put it inside or outside the integration sign. Sum and difference rules. Whether you differentiate or integrate, the property is the same. You do them piece by piece, term by term. For example, the integral of f of x plus g of x is the integral of f of x plus the integral of g of x, and of course, gx. Other rules, when the exponent for x is -1 or 1 over x, it's important to see these two mean the same thing. The result is ln x. E to the power of kx, we divide by k. For the differentiation, we multiply by k. Sine, the derivative is cosine, but the integral is minus cosine. And cosine is, the integral of that is positive sine. All of them, we add a constant. The derivative of tangent was secant squared, so the integral of secant squared x dx must be tan of x plus a constant, so on and so on. The FTC, fundamental theorem of calculus, has two parts. The part that says if you take the derivative of the integral, you get the function back. And the part that we mostly use is the integral of a to b f of x dx. This is a definite integral. This is a number, and we use the limit of a Riemann sum by definition. However, it is faster to use the fundamental theorem of calculus evaluated at the endpoints capital F of b minus f of a, where capital F prime is lowercase f of x. And of course, we have the substitution method, which is the reverse process of the chain. So let's discuss co-optimization. We want to find, for example, two numbers whose sum is 54 and whose product is a maximum. First and foremost, let's remind everybody about the first and the second derivative test when it comes for absolute extrema. A local extremum is an absolute one if it's the one and only extremum in an open interval, meaning if you do the first or the second derivative test, makes no difference. If you happen to have an open interval with one critical point, the local becomes absolute. So in this case, if the two numbers are x and y, you want to maximize the product, which is x times y, subject to the sum x plus y equals 4. You solve for y, you put it into this function, and you count. If 5400 pi inch squared of metal is used to construct a cylindrical storage drum, what is the maximum possible volume? In that case, you are dealing with a cylindrical shape where the volume is pi r squared h. That is the objective function. We want to maximize that. And it's subject to having this much metal, which means the surface area. The surface area contains the area of the base times 2, because the top and the bottom have the same area, pi r squared times 2, so 2 pi r. And then the surrounding, the lateral area, if you cut this open, the width will be the circumference of the circle, which is 2 pi r times the height, and we want that to be 5400 pi. Any of those questions, you can go through the process and let me know if you have any question. I will be more than happy to cover that for you during the office hours. A farmer wants to fence a rectangular field beside a river with 2,400 feet of fencing. The river itself will be one of the 4 sides. What dimensions will give the largest area? Well, you always want to do the drawing. So x, y, x, and so you want to maximize the area, which is x times y. Subject to this much of fencing, which is x and x, 2x plus y. Remember, it's normally 2x plus 2y. However, this side doesn't need any. You solve for y and you put it in there. And now you're dealing with the function of x. Y is x between 0 and 1200. Because if you go back and look at this, first of all, x is a dimension must be positive. If you look at this one and you set the parenthesis equal to 0, x becomes 1200. If you choose x to be larger than 1200, the parenthesis becomes negative, and that means one dimension becomes negative. That means the area becomes negative, which is impossible. And so the domain that we have is 0 to 1200. It's an open interval. We distribute the x, it's a function of x, and to find the critical points, we find a prime, which is 2400 minus 4x. We set this equal to 0, and the CP becomes 600. So we have an open interval with one critical point. So it's either max or mean. It becomes local when we do the first or second derivative test. However, since there's only one, it is an absolute. So the easy way is to find a double prime, which is -4. And we are interested in the sign. Negative means concave down, looking like that, concave down. Therefore, maximum occurs at that point. So if x is 600, you can put it into this one or this one to find the y. And the area is the product of the two, 600 times 1200, or 720,000 square feet. So that's one example of optimization. Another example from a thin piece of cardboard, 10 by 10 centimeters. Square corners are cut out so that the sides can be folded up to make a box. What dimensions will you, a box of maximum volume? What is the maximum volume? So let's look at this example. First of all, you have a 10 by 10 piece of cardboard. You're going to cut X amount from each corner. So if you're cutting X here, you're cutting X here. And therefore, the dimension for this part in between would be 10 minus 2x, the same thing here. Okay, 10 minus 2x. And so you fold it up. The height is x, the width and the length are both the same. So we want to maximize the volume. The objective function is to maximize the volume, which is the length times width times the height. And the constraint is that the length and the width are both the same, 10 minus 2x, with the height being x. So if you replace L, W, and H with what we have here, we have done a question like that with different numbers. Here's the volume. Now, X is between 0 and 5. Why is that? First and foremost, X represents a dimension must be positive. So you're cutting some piece from. If you fold this in half, becomes 5. If you cut 5, there is no box to be made. That's one way to look at it. The second way, if you set this one equal to 0, x becomes 5. So if you choose x to be larger than 5, then this side, for example, becomes what? Negative. You can't have that. So x must be between 0 and 5, which is an open interval. We're going to raise this to second power, becomes 100 minus 4dx plus 4x squared. We're going to distribute the x, we get 100x minus 4dx squared plus 4x cubed. We are going to put it in descending order. Therefore, I'm going to put the 4x cubed first. And this, or this one, doesn't matter. It's a function of one variable x. We take the derivative. V prime of x, or simply V prime, is 12x squared minus 80x plus 100. Since we want to set this equal to 0, we need to factor. So let's factor the 4 out. Clearly, 4 is in common. Number 3 is a prime number, so it's 3 times 1. And then 25 is the product of 1 and 25, or 5 and 5, both of them the same sign. We end up with the following: 4 times 3x minus 5 times x minus 5. When we set this equal to 0, this will give us x equals 5/3. This will give us x equals 5. And of course, we said 5 is out because if you choose a number like 5, you're cutting it in half. Doesn't create any box. We can do the first or second derivative test. The second derivative test is easier. So we take the derivative again, becomes 24x minus 80. We're going to evaluate this at the one and only critical point 5/3. That means plug in 5/3. So 8 times 5. 40 minus 80 is negative 40. And remember, we are interested in the sign. Negative means concave down, and concave down means maximum. Remember, concave down looks like this. Concave down means maximum. So that means x is 5/3. The width and the length are 10 minus 2 times that. Ten minus 10/3. 10 is 30 divided by 3, or 30/3. So it becomes 20/3. Therefore, the dimensions are 5/3, 20/3, 20/3. Their product is the volume. And this is the exact answer. You can always use decimals, but it's a better idea to go with the exact answer. When you multiply those three fractions, we get 2000 over 27. That's easy to do. 5 times 20 times 20, 3 times 3 times 3. So that's what we have. Let's switch gears and look at some integrations. This is using the simple case of a power rule. So this gives us 2 over 5 x to the power of 5. This gives us 3 over 4 x to the power of 4. This gives us minus 7/3 x cubed. Remember, this one, the exponent when it's missing is 1. So 1 plus 1 is 2. 1/2 x squared. And finally, minus 5x plus a constant. For this one, first and foremost, we raise it to the power of 2. We get x squared minus 10x plus 25 dx. 1/3 x cubed minus 10 divided by 2, because the exponent is 1, 1 plus 1, minus 10 divided by 2, minus 5x squared plus 25x and a constant. We are done. We are dealing with exponentials. When we differentiate, we multiply by k. When we integrate, we divide by k. So we're going to divide by 4. So the answer is itself, divide by 4 and a constant. So 1/4 of e to the power of 4x plus a constant. In this case, we divide by negative 3 minus 1/3 e to the power of minus 3x and a constant. Now, just to be clear as to what we are dealing with, we are going to change this to 1/2 x. So e to the power of half of x. So we know we are going to divide by 1/2. So 1 over 1/2 e to the power of x over 2 and a constant. 1 over 1/2 means 2. And that's the final answer. If you see the answer, all is fine. If you don't, change this to 2 times 1 over x. The reason we do that, so we can see clearly we are dealing with natural log. So 2 times natural log of x plus a constant. And you recall we use the absolute value because the domain for natural log is 0 to infinity. We're going to do the same thing here. We're going to rewrite this so it becomes clear. It's 1/2 times 1 over x. This one we know the answer. 1/2 would be the coefficient. So half of natural log of x plus a constant, of course, in an absolute value. Let's look at the definite integral. The integral of a to b f of x dx is capital F of b minus f of x. So we are going to write the antiderivative of x to the power of 7, which is 1 over 8 x to the power of 8. We don't need a constant. When we plug in 1, it becomes 1. When we plug in 0, it becomes 0. So the answer is 1 over 8 times 1 minus 0, or 1 over 8. And again, the tip, as it was mentioned before, even if we use another antiderivative, f of x plus a constant, in the evaluation theorem, the result will be the same because capital F of b plus c minus capital F of a plus c, this one with this one cancel each other. That's why, because the result is a number, we don't write a constant. This is called definite integral. We want to evaluate this. Recall that x to the power minus 1 is the same as 1 over x, and therefore it's a natural log. You plug in the upper limit 2 minus the lower limit 1. ln1 is 0. The final answer is ln2, which is an exact answer, everybody. That's an exact answer. Now, if you didn't put the absolute value, would be okay. However, I want to look at this question where you must use an absolute value. It's the same as before. It's a natural log. But the reason you put an absolute value, because if you don't, ln of minus 1 is undefined. But when you put that, this becomes ln1, this becomes ln2, ln1 is 0. The final answer is precisely minus ln2. You want the integral of sine x dx from 0 to pi. The derivative of sine is cosine, but the integral of that is negative cosine. So we're going to throw in pi and then 0. We put the negative sign out. It makes it easier to keep the negative sign out. Okay, so this is the negative sign. Cosine of pi is minus 1, minus cosine of 0 is positive 1. So the result is negative 2. This negative outside makes the whole thing positive 2. Find all functions g such that g prime is 4 sine x plus 2x to the power of 5 minus square root of x over x. Sometimes you will need to simplify first. Factor, cancel, remove radical notation, etc. Sometimes you will need to integrate using substitution. The idea is that you have to find a way to make life easy. For example, right here, we make up two fractions, this one versus this one. And this one, we change it to the x to the power of 1/2. We know this is x to the power of 1. So we have 4 sine x plus 2x to the power of 4. And the last piece is minus x to the power of negative 1/2. Okay, negative 1/2. And so if you want g of x, you have to integrate the right side times dx. Four times sine gives you negative cosine, so minus 4 cosine x. 2 over 5 x to the power of 5 minus 1 over negative 1 half plus 1 x to the power of negative 1 half plus 1 and a constant. We know negative 1 half plus 1 is positive 1 half. So this whole thing is minus 2. And we rewrite the whole thing and we are done. Needless to say, I'm going to write this as square root of x. So minus 4 cosine x plus 2/5 x to the power of 5 minus 2 square root of x plus a constant is the final answer. We make up 3 fractions. This is 1. This is minus 7 over x. This is 2 over x squared. So we make up 3 fractions. We change this to minus 7 times 1 over x, and we change this to 2x to the power minus 2. We do that so it becomes clear what we need to do. So 1 gives you simply x because it's dx. 1 gives you x. This one gives you minus 7 ln x in an absolute value. What about this one? Let's work on it. Although we've seen it many times, it's 2 over minus 2 plus 1 x to the power of minus 2 plus 1. And as you know, minus 2 plus 1 is negative 1, so minus 2x to the power of negative 1. So minus 2 over x plus a constant. Pay attention to the fact that dt indicates the independent variable is t. So 1 doesn't give you x, it gives you t. Cosine, remember the derivative is negative sign, but the integral is positive sign. Minus secant squared gives you tangent because the derivative of tangent is secant squared. The integral of secant squared is tan x. So minus tan t plus a constant. Working on this, first thing first, we change this to x to the power of 1/3 so the power rule can be used. So this is 1 over 1/3 plus 1 x to the power of 1/3 plus 1. Minus sine x gives you positive cosine x. I want you to know that when you integrate, or you might say minus negative cosine x because the integral of sine is minus cosine x. So minus negative cosine x and a constant. So what happens, obviously, this is plus, this one is 4/3. The reciprocal of that is 3/4. Now 4/3, you can write it in this fashion, is absolutely fine. You could rewrite this in the form of x cube root of x as well. It's all your choice. dv dt is given, v of 0 is given. We are dealing with initial value problem, so let me remind you of that. Any equation containing a derivative is called a differential equation. A function which satisfies the equation is called a solution to the differential equation. An initial value problem is a differential equation along with a specified value of the unknown function called the initial condition. In other words, this one is just a pair 0, 3. The effect of that is when we go through the process with this one, we can find the constant. For now, let's completely ignore that. dv is the right side times dt. Integrate both sides. So this is v of t. What is this one? When we're going to divide by -1, we get minus e to the power minus t. This one is itself and a constant. What you're looking at is a general solution, which is a family of functions. And if we didn't have this pair, we would be done, but we do. So basically, replace the t with 0, v of t with 3. This is -1, this is +1. They cancel each other, c becomes 3. Replace it. This is the answer to this initial value problem, which is a function, not a family of functions. This was a family of functions. This is only one function, and it's known as a particular solution. All right. Let's look at the concept of a substitution. The tip is look for a function u equals g of x anywhere in the integrand, and its derivative du or g prime of x multiplied by dx. So here's the strategy. If you're dealing with polynomials, the more complicated piece is the choice of u, in this case, x squared plus 5. You know the derivative of that is 2x. Therefore, du is 2x dx. Again, I want to make sure we understand this. So because we don't want to mix them up. Du dx is 2x. So du is 2x dx. We're going to move the 2x next to dx. Therefore, it becomes clear that we have u to the power of 30 du. It's a simple case of a power rule. 1 over 31, u to the power of 31 plus a constant. Replace the u with x squared plus 5, and we are done. As always, you can differentiate the final result. It gives you the same answer without the dx. That's how you check if you want. If you have time to check, you can always do that. We are dealing with fractions. In this case, more specifically, we are dealing with rational functions, and I want you to see them side by side because we want to compare and contrast. The very first thing is to simplify. Any fraction must be put in its lowest term before you move on. We can't simplify this for a simple reason. The factor of the numerator is simply 4x plus 1. This is 2. It can't have a factor of 4x plus 1. So what happens when that's the case? The choice of u is the denominator. Now, if I differentiate this, I get 4x plus 1. Therefore, du is 4x plus 1 times dx. To make it clear what we are dealing with, I'm going to put the dx at top so we can see that this is du over u, and this is just a natural log. Replace the u, you're done. As always, if this expression is positive, you can change the absolute value to parentheses. It is not, so you keep it. What is the difference between a and b? You know that the numerator is 4 times x minus 1. Clearly, it can be factored. If the denominator has the same factor, namely x minus 1, we are in good shape, and it does. So you should be able to factor. You drop the common factor of x minus 1, and you write this. It can no longer be simplified. You use the denominator 2x plus 3 as the choice of u. The derivative is 2, therefore du is 2 dx. If I put the dx at top, the numerator has 4 dx, but I need 2 dx. Not a big deal. It's 2 times 2 dx. 2 times 2 dx. And I can put one of those 2's outside the integral sign. It doesn't matter inside or outside. It's just a multiplier. It's a coefficient. So what you're looking at here is du over u, and that we know it to be a natural log. See, I'm not losing this number 2. And so I'm going to replace the u, and I get 2 ln of 2x plus 3 plus a constant and that time. I wanted you to see both of them side by side because it helps. What I'm going to do, I'm going to look at the reciprocal of part B. Look at part B, the reciprocal. Therefore, the answer is the reciprocal of this, because I'm not going to show the factoring again. You can see that. Why am I showing you this question? Because this does not need substitution. This is half of x. This is 3/4. And those are easy integrations. Half of x. X gives you half of x squared. With that, becomes 1/4 of x squared. This gives you 3/4 x and a constant. We are done. So see all of those 3 questions side by side. It helps to see what's going on. Again, I want you to see these 2 questions side by side. Why? This is a rational function. This is not, but both of them in essence are fractions. Therefore, we use the same methodology, which means first and foremost, simplify if you can. And we can't simplify any of it, but if we could, we must. When we can't, the choice of u is the denominator. The derivative is e to the power of t, therefore du is e to the power of t dt. Dt or dx, it's always part of the numerator. I want you to know that. In a fractional format, it is never, ever a part of the denominator. Put it up there so you can clearly see that you have du over u. And that is a simple integral. The result is a natural log. Replace the u. The final answer is ln of the absolute value of 5 plus e to the power of t plus c. And again, some of you may recognize this expression is positive, so you can lose the absolute values. We do the same thing here. We let u be the denominator. Now, if I differentiate this, let me just quickly show you. The derivative of this guy is 2x plus 2 or 2 times x plus 1 if I differentiate it. So du is the same thing times dx. Again, I'm going to put the dx next to x plus 1. And when I do that, I notice everything is in order except 2 is missing. Again, as I've mentioned, in many texts, they solve for dx. You don't have to. Easy way out. Throw in number 2. How do you undo it? It's reciprocal. 1/2. This is the fastest way. Whatever number you need, put it in there, along with its reciprocal. Now, this part is just a good old du over u, just like this one. And so you get half of natural log and a constant. Replace the u. You're done. If you have any doubts, differentiation of the last result will give you this fraction without the dx. Now, again, what I want to do, I want to look at the reciprocal of one of these. More specifically, I'm going to look at the reciprocal of a. And again, the purpose of that is to show we don't need substitution method. Rather, this one is 5 e to the power of minus t. This one is 1. And those are easy integrations. This is 5 divided by -1, meaning minus 5 e to the power minus t. This is t and a constant, and we are done. So the point being, anytime you have a fractional format, it doesn't mean you need a substitution, okay? First, you simplify. Second, See if there are other ways to get around them. If the denominator has one piece or one term, you can normally divide. You don't need to do substitution. Pay attention to the fact theta is the independent variable. Therefore, 5x is not 5t, it's 5 theta. The derivative of cosine is negative sign, but the integral is positive. So positive 2 sine theta and a constant. As I mentioned before, anytime exponent is involved, the exponential functions, the choice of u is the exponent. The derivative is 5x to the power of 4, therefore du is 5x to the power of 4 dx. Let's rewrite this by writing x to the power of 4 next to dx. And when we compare, everything is in order except we don't have number 5 here. Because it's a number, we're going to throw in the number and undo it with its reciprocal. Again, we can do these two numbers. So it becomes an easy case of e to the power of u du, and we know how to integrate this. The answer is itself. Replace the u, and we are done. What happens when sinusoidal functions, sine and cosine, are involved? If you have one of them and the argument has an exponent, the argument is the choice of u. In this case, the argument of sine is x squared. And again, seeing them side by side, it's helpful. The derivative is 2x, so du is 2x dx. We're going to rewrite this by putting x next to dx. Compare and contrast. Well, number 2 is missing. Okay, it's a number. Throw in number 2 and 1/2. So half of sine u du, the derivative of sine is cosine, but the integral is negative cosine and a constant. So this is the negative sign we're going to keep. Negative 1/2 cosine u and a constant, and the u is replaced with x squared. Everybody's happy. Anytime you have sine as well as cosine, if you have both of it, the function that has the exponent is a choice of u, everybody. This means sine x to the second power. So sine x is a choice of u. The derivative of sine is cosine. Therefore, du is cosine x dx. The integral of u squared du. It's a simple case of a power rule. 1/3 u cubed and a constant. So 1/3 sine cubed x plus a constant. Now, what about this case? When we look at this, Which one has the exponent? Sine or cosine? Cosine. So that's the choice of you. What is the derivative of cosine? Negative sine x dx. So what you can do, you can write this as such. Cosine to the power of 20 of x. Sine x, I'm going to put a minus sine x dx. In fact, let me use a different color so you see what I'm going to do. I need a negative sign, so I'm going to put a negative outside. I'd ask you this. I'd ask you to do this at home class. So I'm going to quickly go over that for you. So what happens is we have minus the integral of u to the power of 20 du. So it's minus 1 over 21 u to the power of 21 plus a constant, which means minus 1 over 21 cosine to the power of 21 of x, and of course a constant. That's the meaning. So, in short, the argument has an exponent. The argument is a choice of u. Sine has the exponent. Sine is the choice of u. Cosine has the exponent. Cosine is the choice of u when sine and cosine are involved. What happens when you're dealing with ln x? After simplification and everything, ln x is the choice of u, and the derivative of that is 1 over x. Therefore, du is 1 over x dx, or dx over x. And again, on purpose, I write both because I want you to see they're the same. So we're going to rewrite this so it becomes clear what we are dealing with here, class. We are dealing with u squared du, and that clearly is a case of a power rule, 1/3 u cubed plus a constant, and you replace the u and you're done. Fractional expression. Step 1, can I simplify it? No. Step 2, notice if I differentiate the bottom, I get the top. The derivative of this is itself. The derivative of this one is itself times -1. Therefore, your choice of u is the bottom. Its derivative is the top. So du is the top times dx. And that's really the key. So let's rewrite. By putting dx next to it, we know it's du over u, and that's again a simple case of a natural log. And when you replace the u, you're done. Let's do it again. ln is involved. So that is the choice of u. I hope you know that the derivative of this is 1 over x plus 1 times 1, or simply 1 over x plus 1. Therefore, du is 1 over x plus 1 dx. We are going to rewrite this So it becomes clear what we are dealing with. We're going to write it as ln of x plus 1 times dx over x plus 1. We write it so it becomes easy to recognize that this is the choice of u, this is du, and for now, I'm not going to write the new limits. You can always finish the job, go back to original limits, or if you want to find the new limits, what do? If I plug in 0 here, I get ln 1, which happened to be 0. If I put 1, I get ln 2. So half of u squared going from ln 1 to ln 2, and ln 1 is 0. So you plug in ln 2, you plug in 0, you get the same thing. So half of ln 2 quantity squared. And this is an exact answer, everybody. So you keep it as such. ln 2 is some number to the power of 2 and then divided by 2. That's really the concept, and we are done. A bacterial colony increases at the rate of R of t equals 2.2 e to the power 0.4 t bacteria per hour. If the initial population is 800, find the population after 12 hours. So what is given? Well, this is the rate. So if capital R of t represents the population, therefore R prime of t equals R of t, and we have R of 0 equals 800. According to the accumulated change or the net change theorem, the amount of increase takes the form of an integration, or better yet, a definite integral, in this case from 0 to 12. So replace the lowercase r of t with 2.2 e to the power 0.4 t. So all you have to do, divide by 0.4 and write the same thing. This is 22 divided by 4, or 5.5. Now we're going to plug in 12, we plug in 0, we do the math, and this is the answer. We go with 1 decimal because this number is 8. Number 2 changes to 3. The initial population was 800. Add them up, and that is the accumulated change. This is the population after 12 hours. The population after 12 hours, everybody. Here's the second method. Let's take the integral of that in general. And since it's been done here, since it's been done here, so this one plus a constant, with the initial value being 800. So if you replace the t with 0, you get 5.5 plus c equals 800. C becomes 794.5. And now this is the formula. The advantage of that is, we wanted at 12, we can plug in. We wanted at 15, 20, any number, just plug in, and it gives us the same answer as here in one shot. Again, I wanted you to be exposed to both methodologies. We can model the rate of airflow into the lungs by the function f of t equals half of sine of 2 pi over 5 t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal volume, if the cycle lasts 5 seconds. And here's the note or hint. The time for inhalation is half of the cycle. So if it's 10, it becomes 5. If it's 20, it becomes 10. If it's 5, it becomes 5 halves second. Total amount of air inhalation, therefore, is the integral of this from 0 to this number, 5 halves. Okay. So this is the formula we plug in. All right, so if we want to integrate this, we're going to use this one to be the choice of u, and the derivative is simply 2 pi over 5, therefore du is 2 pi over 5 dt. So let's rewrite this, everybody. Let's rewrite this. Same thing. This 1/2, I just put it out. Sine of 2 pi t over 5. And I have the dt, and I notice this number is missing. Please understand 2 pi over 5 is a number. So plug it in. Plug it in. How do you undo that? The reciprocal, 5 over 2 pi. So I put 2 pi over 5 in, 5 over 2 pi out, and this is now du. So sine u du, and this 2 and this 2 gives us 5 over 4 pi. And I'm not going to write the new limits yet. I need to figure out what the new limits are. If I plug in 0 instead of t, I get 0. So that's clear. If I plug in 5/2 instead of t, I get 2 pi over 5 times t, which is now 5/2. I hope you see that. The result is pi. And of course, the derivative of sine is cosine, but the integral of that is minus cosine. So we have minus 5 over 4 pi cosine of pi minus cosine of 0. So I put the negative sign out also. We know cosine of pi is -1, cosine of 0 is +1. So -1 minus 1. This is -2, everybody. With negative becomes +2, cancels out this 4, becomes 2. So 5 over 2 pi precisely, roughly 0.796. We make it 0.80. And if you go back to the units, liters per second, so this must be in liters. As far as the number of decimals, class, you always go with the exact answer. Then when they mention the number of decimals, you use. All right. Bear in mind, we've done this before. And of course, without those, the independent variable is t. So this is t, and this is sine t. We don't need a constant. So we're going to plug in pi over 2, which gives us pi over 2 plus sine of pi over 2, minus, we're going to put 0. Now, 0 and sine of 0 makes no difference. Both of them are 0. So therefore, the answer is pi over 2 plus sine of pi over 2, we should know it's 1. And if you keep it as that, it's an exact answer. It's perfect. You're done. We're going to replace this with x to the power of 1/2. This has the exponent 1, so it becomes 5x to the power of 3/2. The other one, 3x to the power of 1/2. And so we will differentiate integrate using the power rule. So 5 divided by 3/2 plus 1, x to the power of 3/2 plus 1, and then 3 over 1/2 plus 1, x to the power of 1/2 plus 1. This is 5/2, everybody. Therefore, this is 2. This is 3/2. Therefore, this is also 2. We are going to plug in 4 and 1 to do the evaluation. 1 to the power of 5/2 or 3/2 makes no difference. Either way is 1. So this is 1, this is 1. We have nothing to worry about. But the other ones, 4 to the power of 5/2 means square root of 4, which is 2, to the power of 5, which is 32, which is 64. 4 to the power of 3 halves means square root of 4, or 2 cubed, which means 8 times 2 is 16, minus 4, and the answer is 76. We had done this before. Pretty straightforward. Reminding you of this question we did before. Let u be 25 minus x squared. The derivative is minus 2x, so the u is minus 2x dx. We're going to move the x next to dx so it becomes clear what is given, what is missing. Everything is in order except minus 2 is missing. If I put minus 2, I will undo it with its reciprocal negative 1/2. And now I have the square root of u du with the negative 1/2 in front. I'm not going to put the new limits yet. And this is u to the power 1/2. To integrate this, 1 over 1/2 plus 1 u to the power 1/2 plus 1. And what happens, we end up with 3/2. 1 over that is 2/3. The product of these two numbers is negative 1/3. And if I want to go back to original variable, I can, and I go to the original limits 3 and 4. We can do that. Or I can go to the new limits. How? You put the 3 here, you get 25 minus 9. 16 is the lower limit. You put the 4 here, you get 24 minus 16. And the upper limit is 9. And you can stick with those. Now we're going to plug in. Square root of 9 is, let me use a different color, is 3. Cube it, you get 27. Square root of 16 is 4. Cube it, you get 64. Their difference is minus 37. The product of these two is positive 37/3. Finally, one of the questions we had seen before again, a box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimension that minimizes the amount of material used. First and foremost, reminding everyone that a rectangular solid has the volume, the width times the length times the height, and the surface area, you have 6 sides. The width times the length, the height times the length, the height times the width, and add them up times 2. If it happened to be a cube, all sides are identical, therefore the volume is s cubed, the surface area is 6s squared. So in this case, is the objective is to we must have, okay, so to find the dimensions that the amount of material is used. Okay, we want to minimize the surface area. The surface area is normally the bottom, which is x squared times 2. And in this case, 4xh, because they're identical, but we don't have the top. It's open top. So it's 4xh plus x squared. The volume is x times h. X squared, h is 32,000. We're going to solve for h. And we're going to put it into this function to make it a function of one variable. Four times 32,000 is 128,000. This x goes away. This becomes x only. And if I bring this up, it makes it easier for the next part, which is differentiation. And why is x positive? Because it represents dimensions. In other words, we are dealing with the open interval of 0 to infinity. So I want to differentiate. So 128,000 times -1 makes it negative x to the power of -2 plus 2x. Since we are interested in finding the CPs, that means setting it equal to 0 and so on and so forth. We're going to write this as over x squared and take a common denominator. So this becomes 2x cubed. A fraction is 0 when the top is 0. Which means 2x cubed is 128k. X cubed is half of that. Take a root and you get 40. The units, centimeters. A fraction is 0 when the top is 0. A fraction is undefined when the bottom is 0. X becomes 0, it's not part of the domain. So therefore, we prove there's only one critical point in an open interval. Is this going to maximize or minimize? We don't know. So we go with the second derivative test. And clean up the mess so we can see. So here's S prime. If I differentiate it again, the product of these two gives me 256,000 x to the power minus 3 plus 2. And remember what we should do. We should plug in 40. This is 256,000 divided by 40 cubed plus 2, and that is positive. We've done that before. I leave it for you to double check. We don't even need to know the value. We just want the sign. Positive means concave up. Concave up means minimum. So minimum occurs when x is 40. If x is 40, put it into this or into this, h becomes 20. So if those are the dimensions where h is 20, x is 40, put it into this equation, and you find the minimum surface area of the meat.